Hello again, it's 3 o'clock and we got first day afternoon in Frankfurt at exhibition called Prolight+Sound. And here we have the white sofa again, the ClayPakyTV white sofa, which you know now from yesterday's sessions. And on the sofa we got two guys sitting. One is Gianluca Breda. Gianluca, what's your title? What's your job at?
So I'm working as a sales support engineer. So basically, I'm bringing in the company the tendency of the market, and I'm bringing out of the company what we can provide to our customers and partners. Basically, while the person sitting here on my side is Francesco. Francesco was basically one of the first in Italy and probably in Europe and in the world to start working with the LED technology in our sector, in our fragment of the business. And he is the man behind the A.LEDA series, which we are now going to know a bit more in detail.
Thank you. Francesco, welcome. And everyone, I can assure you, 99% of all users want to know a few details about A.LEDA.
Very good.
And okay, let us start and let us throw in the first question.
Okay.
Why and which LED is running in the A.LEDA LED Wash Light series?
Il prodotto LEDA utilizza il LED della Mostar. Il LED è un RGB white, rosso, verde, blu e bianco. Il motivo per cui abbiamo scelto questo LED sono molteplici. Il primo è una sorgente multicolore e questo ci permette di realizzare un faro che ha al suo interno la miscelazione dei colori, quindi all'esterno dell'ottica noi vedremo un fascio già miscelato. Quindi il primo elemento per cui abbiamo scelto questo LED è la composizione al suo interno di quattro colori fondamentali: rosso, verde, blu e bianco.
So in this unit we are using the O-Star LEDs from Osram. So we are talking about a 15-watt family LED type, which is having RGB and white together. So this is allowing us to have a uniform output. So you don't see the red lens, the blue lens, or the green lens, but you see the final color coming out from the optic itself, which is a very good point, especially if you look directly into the product. And this is important for a reason that we will see in a few minutes probably, which is the control of the single LEDs in the fixture. So the other reasons?
You mentioned it actually. One of the things which is really eye-catching is that you are controlling each individual pixel.
Yes.
The pixel in this sense is actually RGB white, and each pixel can be individually controlled.
Yes.
That's fine from the sentence, but it's also creating a huge amount of DMX channels. How many DMX channels does the K20 have?
Quanti canali ha il K20?
Il K20 o il K10 o il K5 ha differenti modalità di pilotaggio, quindi può essere pilotato con una quantità di 16 canali nella modalità standard, che vuol dire possiamo controllare tutti i rossi o tutti i verdi o tutti i blu o tutti i bianchi contemporaneamente, e quindi ha un numero di canali equivalente a un wash LED standard. Inoltre ha una modalità che permette di pilotare delle macro che costruiscono dei giochi grafici sulla superficie del faro emittente, e questi giochi grafici possono essere anche controllati in termini di velocità di prosecuzione del gioco o dei colori base del gioco o della dimensione del gioco. La terza modalità permette all'utente la massima flessibilità, che significa abbiamo un numero di canali pari al numero di LED moltiplicato per 4 e in questa modalità l'utente può avere la massima flessibilità a creare qualsiasi gioco grafico, qualsiasi gioco di colore. Questo chiaramente è dedicato a utenti esperti.
Okay, so basically we can drive the unit in 3 different modes. The first one is because we do know that the parameter count is something really important with these kind of units. So the first mode is the one which is basically removing the parameters issue, if we want to call it in this way, because the unit is going to be used as a standard LED light. So channel 1 is driving all the red LEDs, channel 2 is controlling the green or blue LEDs in these ways, plus the standard channels, the dimmer, virtual dimmer in this case, the pen tilt, the zoom and the strobe function. Then for a more advanced but easy use, we have a second function which is employing some internal macros, so that basically we can trigger a macro which is already embedded in the fixture by a single DMX channel and controlling it in terms of fade, speed and delay, probably, and delay through other channels. So we do have the possibility to drive the LEDs individually, but we anyway use just a few DMX parameters, while the third option, which is the biggest one of course, is driving every parameter of every LED, so RGB and white of each pixel individually. So in this case the channel count would be 37 LEDs by 4 plus the standard channel, so we are talking about something like 240 DMX parameters in this case.
Wow, quite a lot. So can I ever drive it with what we call pixel mapping too?
Exact.
Okay, so if you would have a kind of smiling face, you know,
exactly,
you get a BMP map, bitmap.
Absolutely, or phrases passing by from left to right or from up to down. Exactly, we can do that. A thing which is really helpful for us is the fact that A.LEDA embed native Ethernet control. So instead of driving a single DMX universe, we can drive up to 512 universes in the same cable. So this is taking away the headache of having probably 15, 20 DMX lines just to drive a few units.
Great, you know, that would have been my next question. Yes, so is it capable of driving ArtNet?
Absolutely, it can drive the ArtNet, and so of course we can decide which DMX universe to choose, but moreover we can also decide to repeat that DMX universe from Ethernet to standard XLR cable. So we get to the first unit in the rig, or in the piece of truss in this case, with the Ethernet cable, and then we turn to a standard DMX cable. This is saving a lot of time and cables to the crew around.
Another interesting topic might be, and many people have asked and be very thrilled about it, is that the fixtures seen, I must say, are extremely fast in movement, extremely fast. And a good question might be, okay, how do you do that? How can you make it physically and technically make it that fast?
Ok, su che i nostri pali sono estremamente veloci. In quale modo riusciamo ad ottenere questa grandissima velocità?
Sostanzialmente sono due gli aspetti. Uno, abbiamo reso la testa del faro molto leggera, utilizzando il dissipatore solo nella parte effettiva in cui deve andare a dissipare calore, mentre tutto il resto della carcassa è in plastica, quindi rende la testa particolarmente leggera. Il secondo aspetto, abbiamo usato tutta la nostra esperienza nei motori trifase, portandoli al massimo delle prestazioni e utilizzando un software estremamente sofisticato nel pilotaggio di questi motori e la combinazione di questi tre elementi, quindi la leggerezza della testa, il pilotaggio dei motori trifase al massimo delle prestazioni e un software particolarmente stretto, ha reso la velocità al massimo del mercato. Non esiste oggi un prodotto così veloce.
Okay, so the first reason is let's say a wise engineering. So by using aluminium heat sinks only and exactly where we really need to use them, so in the point which are influencing more the LED efficiency and the working state of the machine, we were able, and by using Ultramid, which is a special kind of new plastic material for the housing of the unit itself, we are able to keep the weight of the head very low. The second point, and this is something that now we are studying since I think a couple of years, is the maximum exploitment of the pen tilt motors. So with the 300 series some year ago, we set a new standard in the motor driving way, so we are using a completely new firmware and a completely new software way so that the motors are driven to their highest capabilities thus maintaining a very low noise level. And on the other side, if I can add my personal idea, also we are used to work with much more heavy heads. If I think to the 1500 series, where we have bound a huge amount of effects, which means physical material in the light. So playing with something which is probably as heavy as only the lens of the Sharpie, while it's the wall head of the fixture, allows us to be extremely fast, more than the Sharpie itself.
On top of that, I have the impression that the A.LEDA and also the K20, K10 and K5 are really lightweight units. So they seem to be, I don't know, they seem to weigh nothing. So there must be something, and they at the same time look quite solid. So it must be the material which helps to decrease the total weight. Is that correct?
Quindi dice che fondamentalmente i fari risultano essere molto leggeri anche nella versione più grossa, per cui deve esserci un qualche segreto fondamentalmente se utilizzano i materiali piuttosto che qualcos'altro che ci aiuta a renderli così leggeri.
Beh, sicuramente la struttura è una struttura ottimizzata con un'esperienza che nasce dai prodotti alfa. Dai prodotti alfa abbiamo ottenuto il massimo dell'esperienza nel creare strutture molto rigide ma molto leggere, basate su costruzioni in alluminio e rivestimenti in plastica per dare poi l'aspetto, diciamo, estetico corretto. Questo è un po' il segreto per cui, diciamo, il faro risulta comunque molto leggero ma ha una robustezza notevole.
So again, this is a feature which is coming from the Alpha series. So basically, since years now, we are using very special, let's say, tricks or means of making the unit much sturdier than it would be before. So we are using a lightweight material such as aluminium, but in such a way, thanks to special bendings, special treatment to the chemical treatments to the material, so that we can have really lightweight but sturdy units. And again, the special kind of plastics which we are using, which come just from some kilometer from the company, are really allowing us to have a very sturdy and solid unit. Anyway, using a kind of plastic material. Of course, we are talking about engineered plastic and not just a normal plastic, but that's it.
Many other manufacturers are going to, but they're not, you know, we are using heat sinks. We see these are metal plates with a lot of grill surface. Here, the A.LEDA series, we are protected. We have a kind of protection housing which is protecting the hands to go on the hot surface. Is that on purpose? Is it because you wanted to that the fixture appears more colder, and so you don't burn your hands and your fingers by touching it?
Quindi la domanda principale, io non l'ho sentita più, era la questione che il dissipatore è coperto, per cui la tipologia.
È una scelta di progetto molto importante, l'abbiamo ritenuta perché da un lato permette stoccare il faro senza subire ustioni o subire, diciamo, toccare superfici molto ad alta temperatura. Dall'altro punto di vista permette una manutenzione maggiore del faro, cioè la parte elettronica, la parte di dispersione è protetta dalla polvere, quindi non è esposta direttamente all'esterno ma ha una scatola di materie plastiche, termoplastiche ad alte prestazioni che permette di proteggere il dissipatore dell'elettronica, non avere temperature elevate all'esterno e contemporaneamente mantenere una lunga vita del faro.
So the main, as you already said, one of the reasons is that of protecting the operators and the people who are using and handling the unit on stage in order not to have them burned by the unit itself. The second reason is basically to protect the heatsink itself. So the heatsink is extremely important in this kind of light, and having a cover around it avoids dust, confetti, and other kind of nasty materials to get inside the light. And again, this is helping the LED life and the PCBs themselves, which are also quite peculiar in the way they are built.
Also, the light output seems to be more crispy than looking at other lighting manufacturers' products. Is there a trick? Is there a kind of new kind of lens you're using, or how is that done?
Il fascio risulta essere più definito rispetto a quelli di altri prodotti analoghi, c'è qualche segreto anche lì?
Beh, è stata una scelta ottica di base, la maggior parte della concorrenza usa un sistema ottico che ha una maggiore efficienza negli angoli larghi. Quindi noi abbiamo preferito puntare a un'ottica che ha un concetto ribaltato, cioè quando la lente è a posizione 0 abbiamo un fascio molto concentrato, questo ci permette di ottenere la massima efficienza agli angoli così.
So a bit reversing the tendency that we have on the market right now, that sees other manufacturers having a very high efficiency at wide zoom angles. Our choice was actually the opposite, to have a very nice narrow beam, and then to spread it around just, and then to open it so that it's anyway very nice. So instead of coming large and then crossing the beams when we get small and wasting a bit of the light, we keep it really narrow and then we linearly open it, thus keeping a very good definition of the beam itself.
The last question is a must. Fan-regulated ventilation is creating noise, but doesn't need to create noise, because if the heatsink is not producing heat, then you don't need to produce noise. The question is to find the right balance between high-speed fans running and keeping the noise at a really low level.
Necessario, ma abbiamo anche le
Sì, i prodotti che sono stati presentati qui a Prolight+Sound hanno un software che non è ancora ottimizzato al massimo delle prestazioni in termini di silenziosità. Sicuramente l'obiettivo è quello di ottenere il minimo rumore possibile e mantenere comunque una vita lunga dei LED. Il bilancio sarà trovare questo giusto rapporto. Possiamo sicuramente dare anche l'opzione all'utente di decidere che tipo di strategia di raffreddamento usare all'interno del faro, quindi se mantenere comunque un proiettore molto silenzioso anche in condizioni estreme, ovviamente andando a ridurre un pochettino la vita del LED, oppure mantenere una vita più lunga perché uno vuole sfruttare al meglio il faro con più noleggi, e ovviamente questo qui andrà a discapito del rumore, però se uno lo utilizza in ambito di concerti da stadio il rumore non è così importante, quindi si può permettere di allungare la vita del faro semplificando, potrà essere anche una scelta dell'utente.
So basically, of course we have a fan because we need to keep the LED zone with at the temperature which is, as first of all, as low as possible and as uniform as possible, because this is helping the behavior of the LEDs themselves. So what we are going to introduce is a kind of user selectable mode, so for users such as concert use or some kind of big corporate events or other environments in which the noise is not a concern, we can keep the ventilation at a high level so that we lower the temperature and we can work with a very strong light, while in some other case, I of course think to theater, television, drama, this kind of events, the choice will be the opposite. So rather than having noisy fans, we can slightly drop down the intensity of the output, thus lowering also the temperature. And of course then the fans and the electronic system which is driving the fans, because we are not just direct feeding them, will set the right levels and will interact with the LED drivers in order to achieve the best ratio between the two things.
Thank you so much, Luca. I think this was a really, really interesting interview. You have seen that there is huge demand and questions. Everybody's looking at the A.LEDA series, and people want to get it. And this inside information probably is really added value. Thanks so much, Francesco. Thanks so much, Luca.
It's not often speak with people like
That's right. We will continue and have tomorrow another engineer from ClayPaky here on the white sofa. And so far, until then, take good care and enjoy your evening. Bye.